Hey, welcome back to your favorite intermediate algebra course. We're going to look at circles when they're centered at the origin. Okay, so if you remember circles, by definition, the set of all points that are equidistant from a fixed point. So let's say you got this on a Cartesian coordinate system. You put your center right there at the middle, and it's the set of all points that are equidistant. So if this distance here is a radius r, whatever that radius might be, it's all those points that are that same radius length from there, right? And it's every one of them, so that becomes solid because it's an, an infinite amount there. All those points are that same distance from the center. Okay, so you got the standard equation of a circle: x squared plus y squared equals r squared, where your r is your radius. Okay, and that's again only for if you haven't moved it out the center away from the origin. So x squared plus y squared equals r squared. That's what we'll be dealing with here, this first part. So let's draw the circle given by y squared equals 4 plus x squared. So you want to think about, you want to put it in this form right here so you can identify your radius. All right, so let's go ahead and get your x squared and y squared next to each other. Okay, so you got the x squared plus this y squared equals 4. Okay, of course your standard form here is x squared plus y squared equals r squared, so you know that 4 is equal to your r squared, so your radius must be 2. Okay, and you just go ahead and you draw that. We have a center right in the middle, a radius of 2, so we go 2 to the right, we'll go perfectly up 2, perfectly left 2, perfectly down 2, draw our weird looking circle there. Not too great, but anyways, supposed to be a radius of 2 there. So that's how you draw a circle when you're given an equation. So next example, let's say we have a point on a circle and our center is at the origin. So let's draw this. We got 3, negative 4, so right 3, down 4. Our center's at the origin, so this thing looks kind of like that, if you will. Okay. Right, the standard form of the equation of the circle. Okay, so the standard form, of course, x squared plus y squared equals r squared when our center's in the middle. Okay, now the question is, we need our radius, don't we? We need to find that distance right there. So you think to yourself, well, how am I going to find that distance? Because it's not like perfectly horizontal or perfectly vertical, so I can't just count it. It's a little diagonal there, so we're going to have to use the distance formula, okay, from past section there. So you say, well, the distance, what's the distance from your 0, 0 to that 3, negative 4, and that's your radius. So I'll just call it radius. And then we'll do the formula. Use the old distance formula. Okay, name it x1, y1, x2, y2. We go ahead, we plug that in, 3 minus x1 squared plus negative 4 minus the y1 squared. Looks like this thing ends up being 3 squared plus the negative 4 squared. So 9 plus the 16, 25. So our radius ends up being 5. Okay, now we can write, once we have that radius length, now we can say, oh, x squared plus y squared equals r squared. X squared plus y squared equals our radius, which is 5 squared. So x squared plus y squared equals 25. There's the equation of that circle. Okay, so the key there was find your radius using the distance formula, and then you can go ahead and write it with your radius input. Your 5 in this case. Squared is 25. Okay. All right, let's look at another example here. Write an equation of the line that is tangent to the circle. X squared plus y squared equals 5 at negative 1, 2. Negative 1, 2. Okay, so this negative 1, 2 is on our circle. Our center's at the origin. Oops, didn't draw that too good. Anyway, so we're tangent to the circle. Meaning, let me draw this radius right there. Okay, there's my radius back to the origin, okay? So radius r. If you are tangent to the circle, you just touch at that point, you just touch at that -1, 2, okay? And you create a 90-degree angle with that radius there, okay? That's what your tangent definition means when you're tangent to a circle, okay? All right, so what are we going to need to write the equation of this red line, this tangent line? We have a point already on the line. -1, 2, we know it just touches that. That's the only point we know about. And now we need a slope of this as well. So the question is, what's this slope going to be? And if I figure out the slope, I can write the equation because I'll have a point and a slope, and I'll use the point slope formula, okay? So what we're going to do is we're going to use this blue line, that radius, and we're going to find the slope of that. And then we'll flip it over and change the sign because we know that those lines are perpendicular, and that'll give us the slope of the red line, okay? So that's number one here. Let's find the slope of that blue, find slope of blue radius there, okay? Which that goes from that 0, 0 to -1, 2. So we're finding the slope there. So slope equation, y2 minus y1 or x2 minus x1. So 2 minus 0 or -1 minus 0. So we get a -2 for our slope. That means the perpendicular slope, so the slope of the red line would be flip it. So you know how this is -2 over 1. Flip it over, 1 over -2, and change the sign. It was negative, now it's positive. Okay? So now for this red line, I know the slope of the red line is a half, and I also know it goes through this point, -1, 2. So I can use my point slope formula, okay, where this is x1, that's y1. So y minus 2 is my slope, x minus the -1. So, and then I just clean it up. They distribute the half, you know, let me go over here. Y minus 2 is a half, x, a half times 1, half, add 2, which is the same as adding 4 halves, right? Got to get a common denominator there. So I have a half x plus 5 halves. That is the equation. That's my equation of the tangent line at that point. Okay. All right, let's do an application here, a circle. So the beam of a lighthouse can be seen for up to 20 miles. The beam of a lighthouse can be seen for up to 20 miles. So like, let's say we put this lighthouse right in the middle, right? It's like having a radius of 20. Okay, that's this beam. You know, it stops right there. You can see this beam for up to 20 miles, right? In any direction type of deal. Now you're on a ship that's 19 miles west, 19 miles west and 6 miles south of the lighthouse. 19 miles west, so I'm like going, you know, in this direction, -19, 19 miles west, and it looks like 6 miles south, okay, so 6 miles south. Now the question is, am I within, can I see this lighthouse beam, or did I draw this incorrectly and am I actually outside of it, right? Can I see this lighthouse beam? Okay, I'm just going to draw it like that. Okay, but anyways, we're at this point. Who knows where it's at? -19, -6. Okay, can we see this lighthouse beam? Are we inside of this circle? Are we on it or outside type of deal? Okay, well, I'm thinking to myself, is this distance, here's how I would think about this, is this distance within 20 miles? Okay, so if I find that distance, am I within that radius at 20, right? So I'm going to go from 0, 0 to that -19, -6, okay, and I'm going to find this distance. And is that less than or equal to 20, the radius of of this beam, this lighthouse beam. So x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That's 36, negative 6 squared. 36, negative 19 squared. I don't know. Punch that in here. 361. Okay. Oh, you know what I just realized, you guys? I did y2 first. I know this is makes no difference here, but x2 minus x1 quantity squared plus y2 minus y1. I'll just be consistent because I always do my x difference first. Anyways, that was 361. Negative 6 squared is 36, so this ends up being 397. And square root of 396 is approximately 19.925 miles. Okay, so it looks like I can drew that correctly because we're within that 20 miles, and since 19.925 is less than or equal to the 20 miles, then yes, we can see the lighthouse beam from our boat. Okay. All right, make sure you guys bring some questions to class. We'll take a look at some circles.